Welcome to Math 106, Chapter 0.6, where we talk all about functions and graph applications. So we're going to do some recall from, I want to say, some of our geometry days and kind of just put these together. So recall the definitions of perimeter, area, volume, and surface area. Can you guys figure out their definitions and then pair it with their equations? So see if you can pause the video and get started. So it says blank is the sum of lengths or the distance around a figure. Any figure, the distance around it will be called perimeter. Perimeter for, I would say, the rectangular one is 2L plus 2W. That is just going all the way around a rectangle. What about the sum of areas of a 3D object? Well, it's taking all of your areas, the sum of the areas, therefore it must be surface area. Surface area should have this equation. Now, what is the product of three lengths of a 3D object? A 3D object, and the product of those lengths is called your volume. And lastly, the product of two lengths is your area. That one over there. So let's see how this happens in example 1. It says, suppose that the longer side of the rectangle has twice the length of the shorter side, and let X denote the length of the shorter side. So if we're looking at creating just a quick figure, there we go. It says, suppose that the longer side of the rectangle is twice the length of the shorter side. So let X denote the length of the shorter side. So if it's just saying, okay, let X denote the length of the shorter side, that's just saying, well, X is equal to the short side. So that just means that this and this could be labeled as X. So then what about the longer side? Well, the longer side, it says, has twice the length. Longer side has twice the length of the shorter side. So that just means that it takes two of these little sides to make the big side. And this is in proportion to just X is the shorter side. We could also rewrite it where if we wanted to, X is the long side and make these half that distance, but that's not what this one had asked for. So when it says express the perimeter of the rectangle as a function of X, the perimeter is equal to just the distance around it. So now we need to travel all the way around this box and add as we go. So we could say, okay, 2x plus 2x plus x, right? So in our case, we end up having 6 x's. 2x plus x, well, that's 3, plus to 2 more, that's 4, plus another, that's 6. So for us, if you wanted to, this could also be written as 2 times x times 2 times 2x. Just another way, and then from there you can start to chip away and get 6x. Just kind of different ways to achieve the same answer. Now when it says write that equation expressing the area as 28 as a function of x. So now it's just saying that on the inside of that area, let's just take this figure, copy it again, bring it down here. Now it's saying that on the inside, this is 28. Don't know the units, we'll say feet squared maybe, or square feet. So it's saying that its area is equal to 28. Well, what do we know about area? Well, area we just said was the product of your two lengths. Lengths times your width. So that just means we can take away the perimeter if we're traveling around it. And all we have to do is multiply your length and your width. Let's see, length times width, or 2x times x, which is equal to 2x squared. And if we know that the area is 28, that just means that, sorry, area is 28 over here, right? It just means that 28 is equal to 2x squared. So we're writing your area as a function of x. Now C says, if the rectangle represents a kitchen countertop that can be constructed of durable material costing $25 per square foot, write a function C of x that expresses the cost of material as a function of x, where the lengths are in feet. So again, we're going to take, I'll just paste it again. I'll just get rid of this. Don't know why it's not snapping together. There you go. So if we are still talking about the same rectangle, right? So we know that the area is equal to 2x squared. We're now interested in the cost, right? Well, the cost is going to come in. So it says, write the cost function of the material of x, where they're in feet. And it says the rectangular kitchen and countertop is durable, costing $25 per square foot. 25 per square feet. This is, let's say this is square feet here, these units, right? So we're really multiplying the $25 times the square footage, the area. Therefore, your area is 2x squared. So we can bring those two together. So we can just say that your cost is $50 times x squared. That is per your area. If each square foot, if we know your square footage is 28 feet per squared, right? For everyone, it costs $25 on top of that. So together, your cost function in dollars is $50 times based on your x. We're going to try it again in example 2. Now see if you can pause the video and try out example 2 before I get there. So it says a toy manufacturer has fixed costs of $3,000, such as rent, insurance, business loans that must be paid no matter how many toys are produced. In addition, there are variable costs of $2 per toy. Write the formula for cost as a production of toy level. Well, we've done this type before where we said our fixed cost is really your y-intercept. And then we're talking about per toy, it's going to cost $2. Well, this is going to be your slope. So if we're talking about creating an equation, we really have your $2 times x. And then on top of that, no matter what, we're going to get charged your $3,000. So this is your fixed cost. And this is your variable cost. For each toy that's produced, it's going to cost us $2. Then it says, what additional cost is incurred if the production level is raised from 2,000 toys to 2,200 toys? Well, first we need to figure out your baseline, right? When X is 2,000 toys, what is produced? What is the cost? So we can say, well, cost for 2,000 toys is 2 times 2,000 plus 300. That's 4,000 plus 300 is equal to $7,000. So it's going to cost us $7,000 if we make 2,000 toys versus if we raise it to 2,200, we want to know your cost. we're going to do the same thing. So it's going to cost us $7,400. So what is the additional cost incurred? How much did the cost grow by? Well, the difference between the two, 7,400 minus 7,000, is just an additional cost of $400. So by raising an extra $2,000 and, or sorry, 200 toys, it's going to cost us $400. So how many toys may be produced at a cost of $5,000? Well, now they're telling us, okay, well, my cost is $5,000. How many toys does that get us? Well, typically right now we have your equation, right? This is your equation. We now know that your C of X, your cost is 5,000. So that is going to go on the opposite side. And now we have to solve for X. We subtract your 3,000, you get 2,000. Divide by 2. So X is equal to 1,000 toys. So in order to have a cost of $5,000, it's going to produce only 1,000 toys. Now let's see, if you haven't paused the video, I would advise you to pause on example 3, see what you can come up with from here. So it says an average sale at a small florist shop is $24. So the shop's weekly revenue function is R of X is equal to 24X, where X is the number of sales in 1 week. So again, they're just defining what X is. I think that sentence is always super helpful to get us started. The corresponding weekly cost is C of X is equal to 8X plus $600. What is the florist shop's weekly profit function? Well, we know that profit is revenue minus cost. I'm going to do that in a nicer color. So if we know profit, we'll just say P of X is equal to R of X minus C of X. They gave us everything. They told us that R of X is 24X minus your C of X, which is 8X plus 600. So we get 24X minus 8X minus 600, which is equal to 16X minus 600. So this is your profit equation. So how much profit is made when sales are at 120 per week? Well, keep in mind, number of sales, X is the number of sales in 1 week. X equals number of sales in a week. And they told us this is per weeks. So we know that X is equal to 120. So we can put in 120 into your profit because it's asking for profit this time. Didn't ask for cost. It didn't ask for revenue. It said profit. So we get to put it right in. 16 times 120 minus 600. That'll get us to 1320. If we were to do it again with C, it says if the profit is $1,000 for a week, what is the revenue of that week? So now we have to work backwards just a little bit. It's telling us that this is your profit for a week. So it's saying P of X is equal to $1,000. And we need to know R of X. Do we have R of X? Well, we can't directly go there, right? I know R of X is equal to 24X, but we don't know what your revenue is, right? We just have the equation. We don't know what value we can put in, but we do know P of X. We also know that P of X is 16X minus 600. Those are the same values. So we can say that we have 1,000 on one side, and on the other side is our equation. We can go ahead and solve. So we got X is equal to 100. So if x is equal to 100, we can therefore go ahead and put it into your equation for r of x. So it's $2,400 in revenue for your florist shop if your profit is $1,000. All right, so hopefully you found that informative. There are a lot, I should say, a lot more support videos that are like example one. So if you do struggle with structures that are like this, please keep watching the next few videos. They'll be hopefully pretty informative. I do one with surface area, volume, area, different shapes, and so forth. These ones we do see pop up time and time again. And again, we've really hammered in these home from previous sections. Now, this does conclude chapter 0, and now we're going to start to get into more of our calculus-based topic, starting in chapter 1.